I'm up here talking about microservices, but how many of you guys are actually building real microservice systems? Put your hands up. Oh, dear. Obviously we've kind of, by a sort of empirical process, ended up building or figuring out how to build microservice systems in node.js. But we don't have much experience building them in Scala or Go or other things. One of the reasons I do these talks, one of the things I like to hear about is how other people have built systems and the things that you've learned. And what I'd invite you to do, particularly in relation to my talk, is to kind of compare your own experiences, because one of the approaches that we've come up with is answering the question: how do you design microservices? How do you put them together? And in the early days, back in the days when we were using Mongo, you'd sort of have a big 50-page business requirements document, and then you'd kind of go, okay, what services do we build? And we'd sort of guess. And half the time, the services would be wrong, and we'd end up having to refactor them. I guess the central question that I'm trying to ask is, how do you decide what services to build? And typically, you end up in a microservice system, at least in the ones we build, with a very large number of services, even accounting for scaling, where you have multiple instances of the same service. We end up with lots of different types of services. I'll throw another couple of questions out, because this is an interesting topic. We tend towards lots of different types of services. So how many people have a microservice system that has, let's say, less than 20 services? Okay, that's pretty interesting. And how many people have less than, let's say, 80? Okay, so how many people have over 100? Okay, so this is interesting, because that's the place that we go to, right? We like to think that, no, still not there. We like to think that microservices are components. And because they're components, having lots of them makes a bunch of sense, because you get this really nice thing where you have a new feature, a new business requirement comes in, and instead of modifying existing code or extending your database schema, what you do is you add a new microservice. And that's a really nice piece of flexibility, a really nice thing that the microservice system gives you. The flip side is you end up with lots of the things. So how do you maintain an understanding of the system? A junior developer joins your project. How do they know what's going on? How do they tell in this morass of 100 services how the system actually works? And part of what I want to talk about here today, rather ironically, is a visual language for describing systems. So in the first part of the problem, you have to take business requirements. You have to figure out what services to build. And in the second part of the problem, you have to say, well, hold on a sec. I have all these services. Maybe there's more than 100. How do I understand what my system is doing? How can I do that in a visual way? And I know that there's lots of monitoring solutions that show you data flow rates and that sort of thing, right? And you get huge big diagrams, lots of nodes and all that sort of stuff. But that doesn't give you conceptual understanding. It doesn't address the semantic nature of the system. So part of the approach that we've taken there is to come up with a small diagramming language, I guess you could call it, that shows you the semantic details of the system. And one of the key insights that helped us build that, this kind of arose from doing lots of whiteboard sessions and eventually building it up over time. But one of the key insights that came from building these systems was that it's actually the wrong question to ask, what are the services? That is the wrong question. The right question is, what are the messages? Because if you think about it, the services change a lot, right? You might modify them in some way. You might split them into different services because you've got new features. You might build a faster implementation. You might build an implementation in a new language. The messages are a much more stable part of the system. So if you focus on the messages that are going through your system, you end up with a description of the system, kind of a language that describes the system that is extremely useful and easy to parse, because ultimately it's just a list of messages. You can organize them into a hierarchy if you have more messages than let's say 10 or 20, but that gives you a very, very understandable description of the system. So to answer the question, how do you decide, you have a set of business requirements, how do you decide what services to build? Don't ask that question. Ask, what are the messages? You take a business requirement. So let's say user registration. I type in my email and my name, and the website registers me. It sends me a confirmation email. Well, in that scenario, what services do I build? Ask the question, what are the messages? There's a registration message of some kind. And then if I have a confirmation email, there's another message that says, send a confirmation email. And now I can take a look at the messages and I can ask, what microservices are the senders and what are the receivers? So if I have a register user message, it sort of tells me that I should have a registration or registration page microservice. And on the other end of that message flow, I should have a user service, let's say. And then once I do the registration, the user service might emit a message saying, there's a new user, which is kind of an announcement. And an emailer service might say, okay, oh, there's a new user. I need to send a confirmation email. That's a nicely decoupled system. But what I've done there is I've started with the messages, and then I've said, what's on either end of the messages? And that's given me an insight into the microservices that I have to build. And that process is something that we started using. So nearForm, my company, we're a consulting company. We're one of the first kind of Node.js consulting companies. And we've seen the Node.js world go from something that was essentially startups and hacked systems all the way up to, now very large enterprises use it. We're all cursed with JavaScript forever, I'm afraid. But what we've seen over that growth over the last 5 years in our own company is this need to go from the startup view of the world, which is very fuzzy, to a more enterprise view of the world, which is based on having big business requirements documents, properly formally specified requirements. So you get this huge document. What do you do with it? Analyze it into the activities of the system. Turn those activities into messages, and then using the messages, thinking about which microservices on each end of the message, you can then develop the actual services to build. And the nice thing about this system is the messages stay central. So over time, the mapping from a message to which service implements it is something that you can change. So a particular example is, let's say we go back to our user registrations. Well, different types of users might have different workflows. Once the user is logged in or registered, the user might be, I don't know, maybe it's a HR system. So maybe the user is an employee, and some of them are managers, and some of them are contractors. Let's say the service that builds their initial dashboard when they log in is initially an individual service, and it responds to a message that says build dashboard. Now, over time, you want to have different dashboards for different types of users. So you build a service that does dashboards for managers and a service that does dashboards for contractors. You still have the same message that says build dashboard. Of course, the message itself contains other data. One of the data fields in the message might be the type of user. So now you can route the message intelligently, right? So Nginx or Hystrix or Lyft have a really cool load balancer called Envoy. You do intelligent message routing. It's not an ESB, right? All you're doing is pattern matching on the nature of the message. So that if I have a message that says build dashboard and it's a manager, that goes to the manager dashboard building service. But the concept of the build dashboard message remains. So at one level, I can build a diagram that says I have a build dashboard message, and I have a dashboard builder service. And that's it. That's one conceptual level. And when the junior engineer joins my team, I can say that's what's happening at a high level. But then I can go down one level, and I can say, actually, there are 3 implementation services that implement this conceptual service build dashboard, one for each of the 3 different types of users. And when I send a message, a build dashboard message, at that level, I understand there's 3 types of messages going to 3 different places. That's what the focus on messages gives you. It gives you the ability to continuously modify your system in that way and to understand it in terms of those messages. In order to make that work, you have to make sure that you have this ability to intelligently route the messages. And this is another really, really important thing that we've discovered. You need to have, no, that's not me, that's still not me. You need to have a message abstraction layer. So let me ask another question. How many of you are building REST-based microservices, where you're just exposing a REST API? And how does one service talk to another? Are you making direct REST calls between services? Are you using a load balancer? How are you getting from one point to another? Obviously, I mean, some people build their entire systems in REST. Some people use message buses, Kafka, all that sort of stuff. The issue is you still have to solve problems like circuit breaking and throttling. You still have to be able to do this message routing. You know, doing that sleight of hand that I've just described with multiple different types of users and having different layers in the system. If you're just doing REST calls, that's kind of difficult to do. You need to have some sort of message abstraction layer in your microservices themselves. So the act of sending a message is abstracted away. This works out really nicely because it means that the problems of service discovery and all that sort of stuff are hidden away from the developer. And if you think about what this means, it means that when I send a message, I don't have to know the identity of the receiving microservice. That's a really powerful decoupling. If I just have a developer experience where messages come in and I don't know who they've come in from, and I send out messages and I don't know where they've gone, that puts me in a place where I can deploy new microservices and build new microservices without really worrying about the structure of the network. And in doing that, I get a system where it doesn't matter if I'm doing REST APIs. It doesn't matter if I'm describing my APIs using Swagger or not. It doesn't matter if I'm obsessed with Kafka because I want to be able to replay messages or whatever. You give yourself the choice of message transportation system by doing that. But the other nice thing you get is by having a message abstraction layer, you get to capture the message flows. So let's go right back to the start. I have my business requirements. I define a bunch of messages. I get a bunch of services out. And that's the sort of top-down description of the service. But then when I go and implement the service, when I run it in a real system, obviously there's going to be changes. You know, week after week, I'm iterating and I'm putting new features in, all that sort of stuff. So the actual live running system is going to deviate from my original design. But if I can capture those message flows, and I don't need to capture all the messages, I can just sample some of them, I can re-represent that system based on the actual live message flows using the same idea. So from the services, I can pull out the live messages and show those. And again, this is not about showing the data flow volumes between messages or anything like that. This is about capturing the semantic intent. So I want to be able to say there were these show dashboard messages to all these dashboard building services. And at one level, I want to say, OK, I want to see everything at the actual individual container instance level. And then I want to be able to go up a level, and I want to say, I want to see it at the service type level. So there are dashboard type services. Hey, there we go. OK. So I'm gonna run through the slides very quickly now. OK. I should have done it in PowerPoint, absolutely. There we go. Okay. Well, it's a visual language, so it's great that we have a that we have a slides. Okay. So how do you decide which microservices to build? Messages. Okay. This is the flow: requirements to messages to services. This is how we approach building systems. Works really, really nicely. Building a user registration page, right? So these are the two business requirements informally specified. Capture the details, send a confirmation email. That tells me what messages to build, right? Register user, confirm email. And then taking the messages, I think about which microservice is on which end. And I have a registration service and a user service and a mailer service. And then I draw my nice boxes and arrows. So I like to use hexagons for microservices because hexagons are cool. And you can see, yes, we have arrows connecting nodes in a system. But how can we use this representation to really understand what's going on? Well, you have to answer a couple of questions about those message interactions. So one question you can ask is, when do you need an answer? Is the message something that has a response, like HTTP, or is it something that you just send out onto a message bus? So is the message synchronous or asynchronous? Do you need an answer now, or do you never need an answer? Another question you can answer is, who does the work? Does one service do the work, or do many do the work? So sometimes it makes more sense to have 10 instances of microservice and you're round-robin balancing between them to do work. Other times you have different types of microservices that need to know when an event happens in the system. Like you have a checkout page and you need to send an invoice and send a delivery order to the warehouse, and you need to send different things to different parts of the system. So if you put those together, asynchronous, synchronous, messages are observed or consumed, you get 4 basic message patterns between 2 microservices. This is the most common one, request response. If you're building REST-based microservices, this is the one you're using. Right? It's synchronous and the message is consumed on the other end. But you can also have a pub-sub structure where you emit the message, you don't know how many people get it. And if you get the message, other people might have gotten it as well. So you can see in the request response structure, I'm using a solid line to mean it's synchronous, and I'm using a dashed line to mean it's asynchronous. You can also have other variants, which are slightly different from standard models. One I like to call Sidewinder is where you have a synchronous observed message. What does that mean? Well, it might be that you have multiple responses, and you rank them when you get them back. So Fred George has a great example of this where he has a whole bunch of microservices generating insurance quotes, and you pick the best one based on some ranking system. And maybe it does go through Kafka, or maybe you have a little local load balancing library that knows about all the microservices and sends them out and collates the messages back. The point is, this doesn't map to a specific implementation. This is just about giving you a structural model to think about interactions. And then the other one, of course, is synchronous consumed. What does that mean? You send out a whole bunch of messages, but only one microservice acts on it. That's useful in scenarios where you have to do a lot of work. So let's say you're building a newspaper website, and you're getting in huge, big images, and you need to resize them to thumbnails and various things. So you have a whole bunch of image resizing microservices. You don't want to resize the same image 10 times. But you just emit a message going, I've got an image to resize, only one of them picks it. And again, how does this actually work? Maybe it's a worker queue, who knows? The implementation is not important, it's the conceptual model that we care about. So now we have these visual conventions. Service is a hexagon, synchronous message is a solid line, asynchronous is dashed line. Is the message consumed? Solid arrowhead. Is it observed? An empty arrowhead. This gives us a very, very simple way to describe a microservice system. And again, it is kind of based on this idea that we have a message abstraction layer that hides how does message get from A to B. We don't care. So let's put that into practice. So let's build a little search engine for Node.js modules. Here are 3 business requirements. You've got to be able to search for the modules. You've got to be able to index modules as they get published in npm.js. And you've got to be able to show the module details. Right? So there's 500,000 modules. This is a useful sort of thing to build. And this is what it looks like. Right? You type in a search query, and it gives you search results. That's the details page. So it's a tiny little website, 2 pages. So requirement A is search for Node.js modules, turn that into a message. And we namespace the messages a little bit using properties. So I'm going to call this role search, command search, and it's a synchronous consume message because I want a result right away to display to the user. And it suggests that I have a web service that builds the pages, and I have a search service that talks to Elasticsearch or whatever. This gives me my first sort of idea of what I can build. So let me represent that. Right? So I have a web service and a search service, and the message between them, it's a synchronous and consumed message. So I'm doing this on a whiteboard. Right? I'm kind of brainstorming with the team, trying to figure out how to build the system. The next requirement was index the modules. So I have a role search command insert message. And the reason I'm using role search, by the way, is I'm not saying service search, because although in this implementation I have one search service, down the road I might have multiple microservices that implement this entire role in my system. And this is asynchronous and observed because, you know what, when somebody publishes a node module, I would just want to say, hey, here's an event, somebody published a module, do what you like, and there's a search service that decides to index the module. I don't need a response. So this suggests that I have an NPM service that sends this role search command insert and sends it to the search service. And it's asynchronous and observed. Requirement C was show the module details. That's that information page. So my web service needs to be able to say to something, give me those details. So I have an info service that gets the details. And this, again, is a user interaction, so it's synchronous and consumed. I need results now. So there's my info service. So you can see I'm starting to build up this microservice system. And then finally, I have to actually get the data that I'm going to show on that info page. So this is where I get a little bit fancy, right? I'm using a multi-service pattern called scattered gather. So the info service needs to get information from NPM, from GitHub, from Travis, maybe the Twitter account of the author, who knows. It emits a message called role info need part, and it's an asynchronous message. And it waits, let's say, 200 milliseconds for responses from who knows what, loads of different microservices. Collates all those responses together and then shows the page. So that means that if the GitHub microservice is broken because I've exceeded my quotas or whatever, it doesn't block the page. It doesn't prevent the page from showing. In a totally different context, imagine you're building a website for buying film tickets, and the page that displays information about a film shows you the actors and the film and ads and other recommended films and a comment section, whatever. If you build that page this way, if the commenting system is broken, it doesn't bring your site down, the page still displays. So this suggests that I have an interaction between the NPM and GitHub services that get data from those external sources, and the info service, which is fully asynchronous. I send out an asynchronous message, and then those services have 200 milliseconds to send back another asynchronous message that I just collate. So that's what this interaction looks like. So you can see there's the outbound messages, and then they come in. And maybe I have 10 instances of NPM, or maybe I have different microservices that talk to different, get the data from different places, et cetera. But this gives you a conceptual model of what you're doing in the system. And just as an example of this is not completely made up rubbish, here's a photo of a whiteboard session designing a microservice system. Hexagons are kind of hard to draw, by the way, so maybe use circles if you want to. But it is actually practical to sit down and implement a system in this way and think about all the different interactions and then go and build the services. So this isn't complete BS. It sort of works. Okay, let's do a little demo. So if I look at, so I have this little search engine up and running, and I have, there's my services. None of them are actually up and running at the moment. But if I start them all, I'll start them all up, and then okay, so here's my little search engine, and if I type in foo, I get back results. If I type in Pinot, which is a great logger, by the way, Matteo will be speaking later, built this. Some of the guys, super, super fast, Node.js logger, it's the one to use. And I can look at the details page for Pinot, and it goes off and gets data from NPM and GitHub. Now, all of those interactions have been captured, and I use a little monitoring system using UDP to just sample the messages that are flowing in the system. So that means I get to see what the system actually looks like. So if I do it at the tag level, right, you can see that I now have a representation of the live system based on the messages that equates to the original design. I can validate that the original design exists. By the way, you'll notice that there's an extra microservice called suggest down here. So this is an example of I've built some extra features which weren't in my original design. The suggest service it just records the fact that, so you can see, if I search for that. So you can just see it just records the searches that you've made and then gives you suggestions based on searches that it's seen. And you can see that's in the system. And if you think about how suggestions would work, every time I do a search says, hey, this search happened. And the suggest service says, oh, a search. I'll record that in my local database. And then the web is sending, and that's an asynchronous message because you don't care if you lose them. And then the web service, when you're doing a search, obviously sends synchronous messages because it wants to get results back straight away. And that talks to suggest over here. OK. So that's all live code. It all works. If you want to go and check it out, it's on github.com/nodezoo. You'll have to forgive me, the documentation is a little bit out of date because I updated the demo for this talk. But I will be doing that today on the plane. But you can run it super, super simple. It's just a whole bunch of Node.js processes and play around with the visualization engine as well. I'm not saying use this system in particular. What I'm trying to do here is give you ideas for your own systems. That visualizer that I just showed you is like 50 lines of D3. It's super, super simple. The difference is it's not showing you 100 different blobs and data flows between them. It shows you the conceptual semantic level of your system, and I could combine blobs together. Oh, I didn't show you that, actually. So that's an important part of this whole idea. So at this level, this is the top semantic level, right, where I'm thinking about message or service types. But if I want to look at the instance level, you can see that I have a search instance here, and where is it? Another search instance here. So I've actually got two search services running. That's because I need to, I need them for scaling or whatever. And if I put it back to the type level, you can see there's a little 2 up here that tells me I've got 2 instances of those running. I just arbitrarily decided to organize my services in this way. You could combine, you could have multiple levels. So when you have 100 services, you'll see them at maybe 3 or 4 different levels, combining and splitting them all the way down to the individual container level. OK. I've also written a book about it, as Joe said. So if you want to get all the sort of technical details and some of the arguments in favor of all this stuff, the Tao of Microservices, which is on pre-release and is about to be out soon as well. It's a great read, if I do say so myself. OK, thank you very much, guys.